Hello to everyone and welcome to today's virtual event, which is the second of a three-part series for software-defined access with Catalyst Center. My name is Tanner Swift and I'll be your host for today's session. I'm excited to introduce some incredible speakers for you today, but before I hand the mic over to our presenters, we do have a few housekeeping items to cover about this presentation. Today's virtual event will be recorded and made available on demand after the live session, and the playback will also be available on YouTube for rewatch as well. We will provide you with some further details on that at the end of today's event. Also, we'd love to hear from you during today's presentation. During the session, if you have any questions for our presenter, you can submit them via the audience Q&A section on Slido, where we will answer your questions live or during the Q&A portion of today's event. You'll see some QR codes sprinkled throughout today's session where you can participate, so be on the lookout for those. There will also be a couple poll questions for you to participate in throughout today's session. So without further ado, I would like to welcome our first speaker for you today, who is excited to discuss Cisco Catalyst Center, and we'll kick things off by sending it over to Julio Guerrero. Julio, right over to you.
Thanks, everyone, and welcome. So for today's session, we have prepared some of the advanced feature on SD Access. This is the second part of Catalyst Center SD Access series. Okay, so welcome, everyone. Let me introduce myself. My name is Julio Guerrero. I'm a solutions architect with a campus network focused on the use cases for Catalyst Center and Cisco Spaces. Today, we will be presenting with my colleague, Casey Hamilton, that will help us on the demo part. He's also a solutions architect, so thanks for joining us. As you can see, for today, we will do a Slido Q&A, so we can skip this one. And on today's session, as you can see, you will be able to understand the key concepts of SD Access. We will do a small recap on what are the main components of the SD Access fabric. We will go over the LISP PUB-SUB, the publisher subscriber functionality. And we will also explore a little bit on the fabric zones and layer 2 virtual networks with SD Access. Finally, we will go over the multicast, how it's handled, is configured on the SD Access environment. For the first question that we have for you on the poll number 1 is, what is your organization current level of SD Access deployment? Have you explored the SD Access or have you not? Please answer to us. We'll be happy to know. So the answer you can see is not yet exploring SD Access. The initial planning of proof of concept is phased now. The partial deployed SD Access in some areas of your network, or you have fully deployed SD Access across your entire network. Coming up to the agenda, as you can see, we will do the recap, LISP PUB-SUB, Fabric Zone, Layer 2 Virtual Networks, Multicast, and finally a demo with my colleague, Casey. So let's go over the Cisco SD Access recap. We will go a little bit on the fundamentals, blocks for SD Access. As you can see, we have in here a diagram that has all the type of devices, roles, and some very important components that you can see in here, such as the Catalyst Center, the Cisco eyes, some fabric wireless LAN controllers, and so on, right? So here in the diagram, you will see all the architecture highlights with these crucial components that work all together to deliver the intent-based networking that is the SD Access. So the core of the SD Access is the SD Access fabric, as you can see. And this fabric is intelligent core of your network, right? It will allow you to have the network automation, the security, and simplified management. So to understand how this operates, we'll need to take a look on the different type of nodes that will be interacting and the services they work with, right? So first of all, we have the fabric nodes. Think of this as points where you have your wired devices, right? They connect your endpoints, your computer, printers, IoT devices, and so on to the SD Access fabric. So the fabric wireless access points will connect your wireless clients. As you can see in here, we have the fabric edge nodes and then the fabric wireless access points. Both the edge nodes and the wireless access points will enforce the policies that will allow you to get a secure network and will allow you to segment your traffic with the SD Access technology. Now we have the fabric border nodes, as we can see on top. These act as the gateways, right? It will connect you, your SD Access fabric to the outside world with existing layer 3 networks, to the internet, or other enterprise domains, right? They will help you also to communicate with other SD Access fabrics. They will be able to handle the routing to ensure the seamless communication between the fabric. Then we have the intermediate nodes, as you can see in the middle. So this is the part of the underlying transport network that will connect everything in between, right? We don't directly configure these, so we'll they will provide a robust and scalable connectivity between the fabric. Finally, we have a little bit on the control plane nodes that will be like the brain for your network, right? So these nodes will run LISP protocol to maintain all the mapping between the endpoints, identities, and the locations within the fabric. So they, again, there's going to be like the brain, that how it's going to be operating. Everything will be based on the control plane nodes. Finally, we will have some two critical components of the fabric. We have the Cisco eyes that will be the one providing the security, the network access control, authenticating users and devices, and assigning them to specific groups and policies. So ICE is crucial for you to deploy the SD Access Fabric, and this will allow you to have some more granularity and identity-based segmentation. Finally, we have the Catalyst Center that will be in charge also of the automation of assurance of your network devices that will be managing here. And it will act as a central manager platform. It will provide all the network automation, as we mentioned, with a GUI that you can log in, manipulate and manage your devices, create your fabrics, and so on. And it will help you simplify the deployment and configuration of the fabric. So we do also have the Fabric wireless LAN controllers that will allow you to get all the SD Access Fabric into your wireless environment. So in essence, this is all of the components that we need to deploy an SD Access solution. And there are going to be different types of designs, as you can see. We can come from very small sites to large sites, depending on your needs, right? We can see on this example, the fabric in a box is a very small site where you can do a single wire closet with limited survivability and endpoint capacity. This is a very, very small site. Then coming to small sites where we can have multiple wiring crosses and a collocated border and control plane involving some offer limited survivability. Then we have the medium sites that will introduce dedicated border control, dedicated control plane, sorry, and they will also have a collocated border control plane. And finally, the large sites that they will have the dedicated border nodes and the redundancy for both border and control plane, and often you will have a wireless LAN controller and ICE or PSN installed in your premises. So depending on your scale, the redundancy needs, and the physical locations that you have, you may decide on this type of designs. Then there's some components that you can see. There's a fabric domain, and this is also fabric side, right? So there's a slight difference in between. You can see the fabric domain on the left is a logical grouping of one or more fabric sites, right? You can communicate in between two fabric sites in different locations through a transit or peer network. This will allow you to communicate in between and keep the segmentation going in between the two sites. Then we have the fabric sites on the right that it's specifically a physical location or logical location. It will contain the control plane, the border edge nodes, and the fabric wire controller. Depending on your needs, you can also have the ICE or PSN there. So that will depend again on the site. Fabric side will offer scalability, resiliency, and survivability within this single site, right? So think about the domain as a, well, the domain will be allowing you to communicate in between your different fabric sites, and each site you have will be defined as a fabric site itself. Now, in order to communicate with these transit peer networks, as you can see in here, we will have different types of transit. The first one is the IP-based transit that will use IP routing protocols such as BGP or BRF Lite. With these methods, you will be able to connect to external networks, to the internet or data centers using standard IP handoffs. Then we have the Cisco SD Access Transit, as you can see, and this is designed to connect multiple SD Access sites. It will leverage in VXLAN, providing end-to-end segmentation across the sites. Please note that you will require a 50 extra byte MTU overhead for the VXLAN header, so you can connect via a metro area network with all your access sites, for example. And finally, the Cisco SD-WAN Transit will allow you to connect through your SD-WAN fabric, and you can integrate both domains. We can have a session for you in the future describing in more in-depth how can you deploy SD access with SD-WAN. Taking as example the IP transit, as you can see, we'll review these for you. Can you be able to connect multiple sites of SD access deployments, right? This IP transit will design to connect numerous remote branches. As you can see in here, we have a couple of branches. We have a one. The existing one you can use to connect all these sites. Typically, we'll use the internet handoff, peer-to-peer IPsec encryption, the policy-based routing, and it will leverage the traffic engineering and mobile backhaul or LTE. These are some of the typical use cases you can use for IP transit. Now, as you can see on the diagram, we have the IP transit network. We can connect with the border controls into the external networks, and that's a way that you will be using the IP transit. In order to maintain the segmentation and to keep the security group tags or SGT between sites, as you can see, if we're using an IP transit in here, we will need to propagate them across the IP-based transit network. This is for the segmentation you can use. Remember, whenever you create your security groups, you will be segmenting your different type of users, and they will be having an SGT within the VXLAN header, right? You will have your virtual network ID as well. But if you want to keep that across different sites, you will need to either keep the SGTs with an SXP between the edge devices we have on between the WAN sites. And across this transit WAN, you will be able to see that, after it moves from the border node into the WAN, it will keep only the VLAN ID. On the MPLS, we'll keep only that as well. So the option for us is to use SGTs within SXP in this case, for you to maintain the SGTs across the networks and keep the segmentation going. When you are doing the SD access transit, as you can see here, this architecture is tailored as well for multi-site deployments, where you can be connected either like a dark fiber or a metro area network. So this is a key advantage of SD access transit. Will give you the ability to have a consistency for policies within your fabric sites, right? So this will lead to smaller and more isolated faulty domains, enhanced network scalability. And the SD access transit will offer significantly resiliency and scalability for your interconnected campus or metro area environments. So this is the way that you will be keeping segmentation within the fabric sites with an SD access transit. As you can see, we will be using on the control plane as well a LISP, and the data plane, you can see the VXLAN keeps the SGT tag and the VN on the VXLAN header. And since the SD access will keep that over your connection in between sites, you won't need to do any tagging into the SGTs again, right? So the data plane again will use the VXLAN encapsulation. The traffic moves through the SD access transit with the original VXLAN header, and we'll keep this VNID and the SGT as well across your transit. And we will be able to maintain the segmentation within the fabric sites. Now let's take a quick look on LISP PUB-SUB and what is some of the difference between the traditional setup that we do with LISP BGP, and now we have the ability to do the LISP PUB-SUB, right? So there are some enhancements on the SD access fabric control plane that will focus on this LISP PUB-SUB. On the left, you can see the LISP PUB-SUB offer a publisher subscriber model. And with the key benefit of this is the faster convergence, right? Within a fabric site and across the SD access transit. It will provide a foundations for advanced features like dynamic default border. And on the right, you can see the traditional LISP BGP will use an additional IBGP session between the border and a control plane to share all the prefixes outside the network. So let's move a little bit on the benefits. The key benefits that you can have for LISP PUB-SUB within the SD access fabric control plane. Primarily, it will remove the dependency on BGP and certain functions, right? It will lead to simplified border routing designs. And you will experience faster border convergence with quicker propagation of mapping changes. The LISP PUB-SUB will enable traffic path optimization through the features like dynamic default border, and will also facilitate a backup internet option and automates the route linking using LISP extranet. Will offer some enhanced flexibility and resilience with your SD access environment. So what are some of the considerations that you need to take over when you are planning to do the LISP PUB-SUB? This feature started in our Catalyst Center release 2.2.3, and you can see on the release 2.2.3, the support was limited for only newly created Fabric sites running iOS XE version 17.6x or later, and it will be applied to border, control plane, and edge devices only. For existing SD access sites cannot be upgraded to the LISP PUB-SUB. You may need to do them again. So furthermore, the transit control plane can support either LISP BGP or LISP PUB-SUB base site, but not both, right? You can choose one or another one when you are setting up your fabric. And finally, prior to Kali Center 2.2.3, the static configuration of the USPTR, the proxy egress tunnel router, was global under the LISP configuration, right, for all the virtual networks. A requirement that it's now eliminated with the LISP PUB-SUB. And why to choose LISP PUB-SUB? We have been saying. They're going to be giving you a couple of good benefits. The advantages is that will eliminate the BGP to distribute information within the fabric site itself. It will simplify the routing architecture, and we will unlock some capabilities, as you can see, including the first packet forwarding, dynamic default border node, LISP extranet for external connectivity, and the ability to run native multicast over SD access, right? The options that you can see as a remote backup network as well. So there are also some considerations that you need to take in place for LISP PUB-SUB is that it's generally preferred for new greenfield fabric site deployments. Unless you have connected to the SD access transit, you can make it best that was based on LISP BGP, and you can direct the migration from LISP BGP to LISP PUB-SUB. Is not supported right now. It should be support on one of our future releases soon, right? So as we mentioned, part of the faster convergence, as you can see on the left, the traditional LISP BGP, when an endpoint moves or change occurs on the edge node that we have in here, LISP will send a map register message to the control plane to tell, okay, we have somebody moving in between the fabric, and then the control plane needs to update the routing tables, need to propagate them into the border nodes up here, also in the BGP updates, and then BGP updates traverse the network to communicate with it. There has been a change in between some of our endpoints, and it will take some time, right? So these updates that we share in between, they will take some extra time. So this multi-step process introduces some latency into the updates and forward information to the border nodes. On the right, we will review in a few slides how's the process. But as you can see, so this is the slower BGP propagation and updates from the endpoint location. So the initial packets might be directed on outdated locations. So it will result in some drop packets, and you will need to get some retransmissions, leading some temporary disruptions of the service. So this packet loss will indicate that there's some potential data loss in your network. And again, we're trying to mitigate this with the LISP PUB-SUB, with this faster way to communicate every changes on your network. As you can see, for the LISP BGP as well, after the BGP updates have been propagated to the border nodes and they have learned the correct endpoint location from the control plane, the traffic will flow down to the edge nodes with the correct VXLAN label, and will be going to the edge node that is the correct one, right? So this is a little bit the flow when you are getting updates on LISP BGP environment. And now we can see on the LISP PUB-SUB on the right, this is a model where we will have a subscription within the control plane from one of our border nodes, as you can see. It will be subscriptions that will mean that these border nodes are interested in receiving the real-time updates about endpoint location mappings within the SDAccess fabric. So difference between this BGP model is that this control plane relied on, on the BGP routing updates that comes from the border node changes. So this list pops up, the border nodes will proactively subscribe to relevant information from the control plane. Then when there is a change on the edge node, that will register a new endpoint into the edge node itself, or an endpoint location change, the control plane immediately will publish back to the border nodes where is the location, right? So these border nodes will share their forwarding tables because they are subscribed to the control plane, and they will be a faster convergence and a way to communicate faster between any changes or updates on your network. So this is a PUB-SUB mechanism that will make a more efficient way to have the all the changes informed into your network, right? So this is a map register, the list publication that we have whenever any changes happening on your network. So that's when an event occurs, such an endpoint connecting to the edge node or changes in that location. The edge node will send the LISP map register message to the control plane, and I'll open this control plane receives the registration. It will act as a publisher and will send it back to our border nodes. So there's a LISP publication that you can see on the arrow that comes up. After the publication comes from the control plane, that will ensure the border nodes tables are updated. So have the latest information about the endpoints so that they can have a faster reachability information for any endpoints that you have on your fabric. And finally, when the traffic is originating from an endpoint connected to this example of the edge node, again, it will get the information back from the border node across the SDAccess fabric and will send it back down to the edge node itself. So let's move back to the fabric zones, as you can see here. If you have any questions, please feel free to send them over the Q&A, and we'll be answering them in a bit. And let's move to the next topic. This is about the fabric zones and layer 2 virtual networks. So the SDAccess fabric zones, they offer granularity control over the IP pool provisioning with the fabric side. As you can see, moving beyond the 2 to 3 version of Catalyst Center, the scope was for the entire site. These fabric zones are considered like a child sites for parent fabric sites, so that you can see in the demo how can you configure these fabric zones. It's going to be within the fabric site that you have. You will have your fabric zones within. You can see that also the edge nodes are added to the fabric zones when you are defining those. And also the layer 3 virtual networks and the IP pools are provisioned within one or more fabric zones. So you need to be aware when you're designing your fabric, if you're going to go over the fabric zones, please take these considerations. Also, the layer 3 virtual networks and IP pools on the parent side make to sure that you have them before any assignment, so they must be present on your fabric design. And also the only edge role nodes that can be in a fabric zone. You can see that edge nodes can be provisioned in a fabric zone. And finally, the EXPN nodes must reside on the parent fabric zone as well. There are some definitions that you may be familiar with the virtual networks that you will work within these fabric zones. We have the layer 3 virtual networks. As you can see, they have the anycast way for the endpoints on the edges. So the concept of the layer 3 virtual network within SDAccess layer 3 virtual network, it's something similar to a VRF. If you're familiar with VRFs, it will be something similar with this virtual networks. Layer 3 in a traditional networking should be similar, and we'll be providing a layer 3 segmentation with the SDAccess fabric. The Anycast gateway that you will have in here for your endpoints with the layer 3 resides on the edge nodes will have something as an SVI switch-based virtual interface. And all this configuration will be automated when you're creating the layer 3 virtual networks, right? So as you can see, the traffic destined for the enterprise one from these endpoints that we have down here will traverse through the designated layer 3 border nodes, and the IP address pools for the layer 3 virtual network are defined on the Catalyst Center, right? By default, layer 2 flooding is disabled within a layer 3 virtual network to prevent broadcast, unknown unicast, and multicast, known as BUM, traffic that will be flooded across the entire fabric, right? So typically use cases for the layer 3 virtual networks include segmenting client traffic within the enterprise networks. So as you can see now on the second slide, we have a layer 2 virtual network. This is a scenario where the gateway resides outside the SD access fabric, for example, connected via on a layer 2 border node. In this design, the gateway for the subnets within the layer 2 virtual network is typically a firewall or layer 3 device connected to the layer 2 border. And you can see the gateway configuration for external devices are not managed by Catalyst Center. So this is one of the challenges we have. The traffic destined for the enterprise one from devices on this layer 2 virtual network will traverse the designated layer 2 border nodes. And it's a layer 2 extension. The layer 2 flooding is enabled within the fabric on these layer 2 virtual networks, meaning all the broadcast, unknown unicast, and multicast traffic will be flooded across an extended layer 2 domain. Some of the use cases, as you can see here, is for operational technology, IoT segments, and BMS system segments as well. Now, as you can see, this layer 2 virtual network feature, it has been introduced in the Catalyst Center 233. As you can see, the functionality was put in here, and the requirements for wireless support completely for layer 2 and wireless come up on Catalyst Center release 235 and iOS XC 1710. One of the key characteristics is that layer 2 VNs do not require an associated layer 3 VN, removing the overhead for this association in certain scenarios. To to create a layer 2 VN, you need to enable the preview and SD access. As you can see, depending on the version you're running, will get you into this preview or not. When configuring the layer 2 border handoff, the VLAN associated with a layer 2 VLAN is listed under the layer 2 virtual networks with a gateway outside the fabric option that you can have in here. My colleague Casey will take you a little bit more into how to configure the virtual network and the fabric zones. And a little bit of comparison in between the layer 2 and layer 2 virtual networks is that for the virtual network identifier, layer 3 VNs utilize both. As you can see, the layer 3 VNs and the associated layer 2 VNIs, while the layer 2 goes only with the layer 2 VNI. For flooding about the broadcast unknown unicast and multicast, traffic is disabled on layer 2 VNs, but it's enabled on the layer 2 virtual networks. And finally, the gateway for layer 3 VNs resides on the fabric. As you can see, the gateway here, it's residing on the fabric, the SVIs. And for the layer 2 virtual networks, it will be outside the fabric, or there is well be known, right? In a fabric inter-VLAN routing, as you can see, by the either by the firewall, is not a feature on layer 3 VNs, but it's possible on layer 2 virtual networks. IP address pools for layer 3 VNs are configured within the Catalyst Center, but no for the layer 2 virtual networks. And as you can see, a same subnet VLAN endpoint scale is very scalable. You're limiting the number of endpoints with a layer 2 within layer 2 virtual network domain. And the use cases, you can see there's suitable for segments for most enterprise deployments, and for layer 2 VNs for isolated VLANs, broadcast is required on VLAN, and the gateways should be considered to be on a firewall. Now, moving a little bit into the multicast topic for SD access multicast, you can see a little bit of the summary that we have in here. So the support that we have for deployment models on multicast, we have two options, the head-end replication and the native multicast. The head-end replications involves forwarding multicast traffic within the overlay network, so it can operate in a multicast over unicast scenario and can be supported from the initial releases of SD access. So these methods also support up to 8,000 multicast groups, and it will be dependent on the platform, right? As you can see, there will be platform dependency on how many groups you can deploy on a head-to-head replication. For native multicast, on the other hand, the forwards moves over the underlay, and it will operate a multicast over multicast scenario. And I was introduced with Catalyst Center, the one of the early releases, and iOS XE also all release it was introduced. The native multicast supports up to 1,000 multicast routes, as you can see, with a specific mapping range from the addresses from 232.0.0.1 to 232.0.32.32. Now, about the head-end replication, as you can see, they support two modes, right? The ASM, that is any source multicast, and the SSM, that is the source-specific multicast within the overlay. For the rendezvous point placement on ASM, as you can see here, it should be can either inside or outside the fabric. The similarity for the multicast source can also be located inside of or outside the fabric. For the rendezvous point redundancy on ASM overlay, it can be provided by the multicast source discovery protocol. And the configuration, as you can see, it's fully automated by Catalyst Center. As a general rule, as you can see, the multicast packets in this mode are encapsulated into VXLAN, and they will be forwarded into unicast packets on the edge node separately. So the native multicast, on the other hand, support modes on the overlay also do support any source multicast and source-specific multicast on the overlay. However, within the modes on the underlay, only SSM is possible. For the rendezvous point placement, as you can see, can be either inside or outside the fabric. Same for the multicast source placement. The redundancy will be handled again by MSDP, and the configuration will be automated by Catalyst Center only when the LAN automation feature is used, right? So remember, if you are using LAN automation to deploy your fabric sites, you can go to native multicast. And finally, a general rule, as you can see, all the packets will be encapsulated on VXLAN as a multicast and forwards to the edge nodes through the underlay multicast tree. A little bit on the multicast routing terminology, as we are describing a couple of those already. So think as a multicast stream as a flow of multicast packets originating from a specific source, as we have on the top. These packets will be addressed to group addresses, as you can see, and will act like a channel, right? So if there are some receivers that are interested in receiving this stream, they will subscribe to this group address. And as the multicast traffic enters a layer 3 routing, we'll have the first hop router. It will take some extra responsibilities on these type of devices, as the one that we have represented here. This path will take through the network, and it's represented by this tree. And well, the host will join the multicast group using IGMP, and this IGMP join message within the layer 2 go to their default gateway. We'll also have the multicast device and the rendezvous point that will be helpful for you. And the rendezvous point will act as a central meeting place for resources sending in a group of receivers wanting to join the group. And then we also have the outgoing interface list, and it is crucial part of the M route, right? So as you can see, the comparison between the, any source multicast and source-specific multicasting here. For ASM, as you can see, the host only needs to know the multicast group address and request to join to that group from any source. The first hop router will need to run IGMP version 2 or above, and the network requirements for the rendezvous point. So the PIM sparse mode will need to be enabled on all the interfaces or network devices. And a difference with SSM, as we can see here, a host will need to know both the group address and the specific source. The first hop router will need to run IGMP version 3, and a specific range for SSM runs on the 232.0.0.0/8 domain, right? Similar to ASM, as many deployments, the PIM-SPAF mode is often used in all the interfaces for SSM as well. Now, if you can see on the head-end replication with ASM, a little bit on a closer look, the initial status of a head-end replication, the receivers will be connected to the edge nodes acting as LHRs, while the multicast source and the outside of fabric of the rendezvous point will exist over the on the overlay. Using the endpoint NP space, then we have the PIM-SEM, and will be enabled on the overlay between the fabric sites and externally within the BNBRFs. And then when the sources start to stream multicast traffic, the first hop router will receive the multicast stream and will trigger the any source PIM register towards the rendezvous point. Then the rendezvous point will inform peer rendezvous points about the source via MSDP. If there are no receivers active, the rendezvous points will send a PIM register stop messages back to the first hop router and will wait for any request. Then when there are some clients requesting the multicast stream, and the clients are connected to the edge node, the LHRs, as you can see, they will request a multicast stream by sending the IGMP message. The join message will go from any source multicast group, and then the edge node will receive this join and triggers into a PIM join towards the rendezvous point. Since the RPs have the same IP address, the Anycast, and a hashing algorithm within the LISP next hop towards the rendezvous point, it will determine which rendezvous point will receive the join from these requests that we have from here from the receivers. And the Fabric RP has now the knowledge and triggered a PIM join towards the first hop router. Finally, the first hop router from here will be able to add the interface facing the RP and outgoing interface list and start forwarding the multicast traffic down to the receivers. And finally, the multicast stream starts being forwarded to the receivers. On this stage of the head-end replication on ASM, the border node acting as an RP will receive the multicast stream from the first hop router. So we'll start flowing down, getting through encapsulated via VXLAN into the receivers. So these copies will be encapsulating from the multicast source into the border devices, through the fabric into the edge devices. And finally, these the LHR or edge devices will receive the uniquest VXLAN packets, will be encapsulated and forward that to the original receiver that we have on the bottom. In order to do a configuration of a multicast, if you can go to the fabric sites and you select one of your fabric sites itself, you can go and then configure multicast. It will allow you to go into a workflow defined on the Catalyst Center to enable this very quickly. We will prepare a session for you to get deep into the multicast configuration and with a demo. And after you click on configure multicast, you will go into the workflow itself. You will be asked in which replication mode you will be need to go. Either we can do head-end replication or do native multicast. As you can see, for the head-end replication, it will be performed by the multicast first hop router with the just selecting this part of the configuration will take you into the selection of the virtual networks where the multicast will be applied, and then selecting the pools that we have in here. So at this stage of the multicast configuration, we have reached the IP address pools that need to be associated with this campus virtual network that we already selected for the multicast signaling to go through. And finally, if you get to the head-end replication with the ASM, every non-RP fabric needs to have just one IP address. The RP fabric devices need to have more and more common IP address, and it has RP. So after you select that, You will be able to check the multicast node, either the ASM or SSM. We will do ASM as we mentioned. By selecting the ASM, that will indicate that the receivers will join these multicast groups as we talked without a specific or particular source, and the network will rely on the RP to facilitate the discovery of multicast resources. And finally, you can do the RP mapping for the rendezvous point. As you can see, in this stage of the configuration for the campus virtual network that we have selected in here, we will have the RP devices that you can select within the fabric, and that a maximum of 2 RPs that you can be configured between this type of setup with the Catalyst Center. It's up to 2. Finally, when you complete the configuration, you will see your devices marked as rendezvous point in here. And the RP typically can be configured on the border nodes, but edge devices are not supported. And the control plane node and the rendezvous point should be okay. So some considerations when you're finally doing the SSM configuration instead of ASM, the flow will be exactly the same as we see before. As a result of provisioning, you will have some extra commands that IPP, BRF, and the BRM SSM default. It will be pushed when you are configuring your devices. You can make a check on the configuration that is pushed on your fabric devices. And finally, with the host subscribed to the SSM channel, it means by IGMP v3, announcing the desire to join a group, GSRs, the RP is not contact in this process by the receiver, okay? Now we have a second poll here. As you can see, we would like to know if you already have SD access, which type of fabric connect you are using. If you are not connecting your fabrics with any transit, if you are using IP-based transit, SD access transit, or SD-WAN transit, we would like to know. And now it's time for our demo. If we can move forward. Thank you.
All right. Hello, everybody. My name is Casey Hamilton. I'm a solutions architect at Cisco, and I'm going to walk you through a bunch of the concepts that Julio just covered for advanced SDA. First off, I do want to show you the version I'm currently running. I am running version 2.3.7.6 Catalyst Center. And the next thing I'm going to do is go to the fabric. So to get to the fabric, what you'll do is you'll click the menu icon and then click Provision, Fabric Sites. You'll see we already have 2 fabric sites created, London, RTP. First thing I'm going to do is go over how to configure LISP PUB-SUB. To do that, you'll go to Transits, and you'll click Create Transit. Let's do it. And here's the important piece. For transit type, you have a few options here. One, you can choose IP-based, which is what we currently have set up in this lab. But you have the option to do LISP PUB-SUB or LISP BGP. Julio covered these during the presentation. Now, SD access LISP PUB-SUB, what that's going to do is allow convergence between your fabric sites over the WAN and let LISP PUB-SUB propagate that information to the control plane nodes and update the database accordingly over the WAN. So this is specific for that. So you'll want to select that and then configure the transit. For the purposes of this demo, we are running IP-based because we do not transit the LISP PUB-SUB over the WAN. However, we do transit it internally within the LAN of the fabric sites. Now, next, I'm going to show you how to do that. So we go back to fabric sites, and we currently have a fabric deployed in London. And to configure LISP PUB-SUB, what you'll want to do is declare and assign a control plane node. To do that, I'm going to select the border node, and right here, control plane node, I'm going to select this. It opens up the workflow to either select LISP PUB-SUB or LISP BGP. LISP BGP is the older style that does not use the PUB-SUB convergence, where LISP PUB-SUB is the newer one that Julio just covered. You'll want to select this, click Add, And now we have this toggled on. Next, what you'll want to do is click add and then click deploy. And I'm going to go ahead and schedule this for now. You can select preview and deploy if you want to review the configuration that will be pushed, or you can schedule it for later. Okay, so I'm going to select now and then click apply. It's going to run device compliance check, make sure everything's good to go. And then I'm going to click submit. And it's going to update the devices. And usually that was working just a second ago. What was expected to happen is this will turn blue. It'll go into the control plane and be configured with LISP PUB-SUB. The next thing I'm going to cover is layer 2 virtual networks. So Julio was covering this during the presentation. One, we have layer 3 virtual networks, and we also have layer 2 virtual networks. The big thing here that you'll notice is on layer 3 virtual networks, when you create virtual networks, essentially what it is it's a VLAN, and it's actually tagging and automatically generating VLAN IDs. So these you do not have any control over for layer 3 networks. However, what you can utilize is layer 2 virtual networks to specifically define manually what VLAN IDs you want to use. Let's say you want to create like a voice VLAN for phones. You could do that by going here and then creating your own virtual networks. Okay. And the next thing I want to cover is I'm going to actually go over to our existing, London. And what we're going to do is go to view site hierarchy. You'll see we have 2 fabric zones already created. I'm going to show you how to create these fabric zones in just a second. But essentially what it allows you to do is micro segment what IP pools are dedicated to what fabric zones. So you can get very granular when it comes to the global routing table within your fabric. Okay, so I'm going to go to site 1. And here you'll see we have our devices. They're all here within the fabric. But what I'm going to do is declare within this specific site, I'm going to declare edge 1 to be a part of this fabric zone. And therefore, any IP pools under this specific site will be defined for this edge node. Usually, so that's again the new error that's coming up. So I need a control plane first is the error I'm getting, but for some reason it's not working right now. My apologies. Now, what will happen is you'll click edge 1, you'll click deploy, and then it'll turn blue. It's as simple as that, and then it will be added to the fabric zone. Okay. Now I'm going to go back to fabric sites, and I'm going to create a new site. Let's do it. And here it's detecting fabric sites that we have mentioned, or it's detecting actual sites that we have mentioned within the network hierarchy. As you can see, we had RTP and London already configured. However, Australia was not configured. So I'm going to go ahead and select the fabric site location here. And here we have our full network hierarchy under it. Next, I'm going to click next here, accept the defaults for wired endpoint data collection. Click next. I'm going to select closed authentication. What this does is enables 802.1x for ICE, where it can use various methods, either MS CHAP or certificates using EAP-TLS to authenticate devices and users onto the network. And I'll click next here. Now, this is where you actually configure the fabric zones. One thing I could do is I can set these up later. I'm going to go ahead and set them up now to select, and I'm going to select that and then go down, and I'm going to define which site I want the fabric zones for. So I'm going to select dev and HQ. Click next, and then I'm going to go ahead and select next, and then select now. You can also preview and deploy, and then I'm going to go ahead and deploy. It's going to run a check, and then I'm going to click submit. All right, it happens fairly quickly, and I'm going to click view fabric sites. Okay, now we can see we have Australia fabric site created. My next step is going to be to actually discover and provision devices over to the site. I am not going to do that on this call. We already have our devices in London, but I do want to show you how this looks. We have our fabric zones here. It's going to be very similar to London. I'm going to select Australia. Once I discover and provision devices to Catalyst Center, it's going to show up here within this. And then we have our view site hierarchy and our 2 fabric zones. So any IP pools configured under Sydney, under the dev sites and the HQ sites, I can microsegment, which IP pools should be dedicated where within a total fabric, and utilize these fabric zones to microsegment it further. So I click dev, and then I could assign the edge nodes there. And that concludes our demo of the concepts that Julio covered. Julio, I'm going to go ahead and hand it back over to you.
Thank you, Casey. So let me share back again quickly. You should be able to see my screen in a second. Perfect. So some of the key points to remember about this session, you can see some of the SD access architecture points that we have been going in the beginning. What are the types of devices, the roles that they play, and how does the Catalyst Center is very important for you to deploy your fabric. We saw a little bit of the transit options that we have for the SD access sites as IP transit, SD access transit as well. We will try to focus on one session for the interaction between SD access and SD-WAN transits. How can you integrate both domains? We saw a little bit on the fabric zones and how the layer 2 virtual networks will help you to have more granular segmentation in your networks, and also how does the SD access LISP PUB-SUB works and how will help you to have a better convergence on your network sites. Multicast consideration as well as we saw, and we will also be preparing another webinar for you for multicast, so please stay tuned. And well, finally, some key points. After the key points, we have some Q&A. If you have any questions, we'll be happy to answer those for you, okay?
Thanks so much, Julio, and thank you, Casey, for our demo today. During this session, we have reached the Q&A portion of today's event, so we'll go ahead and take some time for questions now. Just a reminder, if you do have a question, you can use the Q&A section via Slido. Use that QR code on your screen if you would like to participate. Also, those poll questions are currently live for you to provide a response on as well. Julio, I would like to get to this first question here. What are the primary benefits of using fabric zones in an SD access deployment?
Thanks, Tanner. So the fabric zones will provide enhanced segmentation beyond the edges by creating these logical admin groups for the users, devices, and applications. So the fabric zones will allow you to do stricter security policies between zones and isolate the layer 2 broadcast domains, leading to smaller fault domains and improved security and manageability with these different groups on the same fabric site.
Great, thank you. Here's another question. In the context of SD access transit options, what's a key difference between IP transit and SDA transit?
Yeah, I can take that as well. So the IP transit will use traditional IP routing over existing WAN or internet connection, and will be giving you potential higher latencies requiring some coordination of the existing IP infrastructure. The SD access transit, on the other hand, will use the dedicated SD access fabric as a transit network. As we saw, you can use a dark fiber, a metro area network, and will help you enable consistent policy end-to-end segmentation. You will not need to do a retag of your SGTs. I will be using the same VXLAN as LISP across the connected SD access site, and will be used typically on geographically close deployment sites.
Great, thank you. I do want to get to this question that we have from Ali, just came in. Can we still communicate between VLANs that exist in one fabric zone but not in the other fabric zone?
I think no, they should be isolated. If you put it into different fabric zones, they will be part of the different um, the fabric domains. So no, I think no.
Great, thank you. Thank you for expounding on that. A couple more questions here for you. What is the main advantage of the LISP PUB-SUB over the LISP BGP for the SD access control plane?
I can take
As-
that one. So the primary advantage of LISP and LISP PUB-SUB is faster convergence. Instead of relying on BGP updates to propagate endpoint reachability information to border nodes, what LISP PUB-SUB will do is it's going to use a publisher subscriber model for direct and immediate notification from the control plane. What this is going to do is it reduces the time it takes for the network to adapt to changes, and it also minimizes potential packet loss and also service disruptions.
Beautiful. Thanks so much, Casey. Here's another question here. What's the fundamental difference in how receivers join multicap groups in any source multicast in comparison to source specific multicast within SD access?
Yeah, I can take that one. So in the any source multicast, the receiver only need to know the multicast group address and send the IGMP join to that group, regardless of the source. With the network will rely on the rendezvous point for source discovery. And in SSM or source-specific multicast, the receiver must know both the multicast group and the specific source they want to receive from. So they will indicate this via IGMP v3 message. SSM don't require an RP or rendezvous point to source discovery within the SSM range.
Great. Thank you so much, Julio. We are winding down here for time on questions, but I do want to give each of you the platform here once more. Casey, I'll start with you. Do you have any last words or comments that you'd like to leave for our attendees before we do wrap up here?
Well, thank you everyone for joining. I hope you got a lot of value from this presentation. Be sure to check out the post discussion thread where if you have any questions, we'll get back to you on it. We do also have a third of this series, the final series, coming up next month in May. I believe it's May 13th, if I'm not mistaken. And what that'll do, we're going to go over SDA monitoring. So be sure to check that out.
Great. Thanks so much, Casey. Julio, I'll kick it to you as well. Do you have any last words or comments for our attendees?
No, again, thanks all for joining. If you have any other questions, feel free to post them on a link that will be shared with you, and we'll see you on the next time. Okay, thank you.
Great. Thanks so much. Want to huge thank you once again to Julio and Casey, as well as Kavita, our producer, James McDonough, and the whole team for bringing your knowledge to the Cisco community today. If you do have an additional question for our presenters, we'll keep that Q&A panel open on Slido for a couple more minutes. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. As mentioned, you can follow up with any further questions about today's event, view resources from today's session, and view its recording through our post-webinar discussion thread on the Cisco Learning Network. Come over there, talk to us, let us know how things are going. We'll be happy to help you out on your learning journey where we can. We also ask that you please take a moment in answering our post-event survey via Slido, as it helps us prepare for some future sessions. Just take a few moments and answer a few questions for us. That would be greatly appreciated. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.